So hi guys, today we have another problem, that is divisibility tree, and the question states that you are given a spanning tree. Basically there will be n nodes and n minus 1 edges, and also the number of n that will be even, and you have to tell how many disjoint sets are there, that the all the sum of the nodes that will be even or not. If that is even, then we can make a disjoint set from this graph. So basically, let us take this example, and you can clearly see that if we remove this edge, then we can have this turn set, right? And there is only two nodes, and two is even, so it is allowed. And also, they removed this node, sorry, this edge also. So they also made another disjoint set, that is this one, and that another one is this one. And all these disjoint sets have uh, even number of nodes, right? So we have to return the maximum number of parts that we can to make to have this disjoint sets, and that the sum of the nodes will be even. So that will be our question, and let us discuss how can I make the approach from it. So we took the given example that we had. Basically, what I have to do, I have to cut here and here. So how can I identify where should I cut? One thing that is sure, that we can make a cut when we have the information that how many nodes are there in the leaf part, right? Means suppose we are now here, now one, we are now here, and we have to know all the number of the nodes of all subtrees, right? For here that is 2, and here that is 4, and here also that is 3. So we need to have this information to confirm our card. Now you can think that, okay, so in this side we have two nodes. So obviously, if I make the cut here, then I can get a distance set that will be that will satisfy our condition, right? So again, for this angle, this will be same. So we can make another cut here. So it is also right. But here you can see there is only three nodes. If I cut from here, then it will not satisfy our condition, right? So we cannot cut here. And we also have to take this node also to make this remaining disjoint set an even number of sum of the all nodes, right? So we need to have this information for each node. So how can I get the numbers of the nodes? That is only, there is only one way, that is DFS. So if I traverse from here and go to the leaf node, and when we reach to the leaf node, we have to return 1 here. And also we have 1 here, and we have to include this node also. So you have to add another one and return to the root node. So here the answer will be 2 for this subtree, right? And we have to follow this rule for this subtree also and this subtree also. Like if I make the calculation, that will be, we will start from here, and we have already visited this part. Now we can go to this part, and we have reached the leaf node. So we can return 1, and for here we can also return 1, and we have to sum up these values and return 3. Why 3? Because we have to consider this node also, right? So that's why we have 3 down. So it will return 3 from here, and and also we have to add for this 6, and we will get 3 plus 1, that is 4. So this is how we can get all the informations of the sum of the nodes. So yeah, also, okay, so there is another condition, that is we cannot apply this rule when all the Some of the all nodes are odd. Now, if I take this node, sorry, this graph, 2, 3, 4, and 5. So you cannot make any cut. Why? Because you can clearly see that the number of nodes that is odd. So how many number of edges will be there? That is n minus 1. So the number of edges will be even. If I remove one of the edges, suppose we are removing this edge, so you can think like, okay, so it is making a difference that the condition satisfies also. But you can clearly see that for the other set, it is not satisfying. Why? Because of the edges will be even in this time. So if we remove one of the edges, then other set will have the odd number of edges. See here, we have odd number of edges, but that cannot be allowed here. So for this reason, in the question, we only can have n number of values that is even. So we don't need to think about it because in that all test case, all the n number that will be always even. So this is an intuition why they are giving uh, even number of nodes. And so this is the idea. So let us move to the coding part. Then we can have a clear idea of this algorithm. So, okay. So let us move to the code. And one thing we have to discuss also that we have taken this example, right? And we know for DFS we have to store a visitor array, but here we do not need to have any visitor array. Why? Because this spanning tree will not make any uh, cycle, obviously. So we don't need a visitor array, but we have to keep track of the parent node. Why? Because suppose we are moving from here and we are now here, and we have to check all the adjacent nodes, right? But we cannot check these adjacent nodes also. So only we have to keep store of the previous node or the parent node. That will be enough for us. So let us make the graph. And one thing again, because they are giving in this way, means they are just mentioning the connections of the nodes, and we have to make the graph from it. So let us make the graph. Vector, vector. We are taking vector here. That will be graph, and it will be n plus 1. Why? Because this is the one based indexing, and vector in. So for the outer size means the size of the eye, that is n plus 1, and for inner size we currently don't know. Until and unless we are traversing these edges, then we can know the size of the individual nodes. So let us run the for loop for the edges. Int I is equal to 0, and it will be edges of size and I plus plus, and we have to keep all the nodes and the edges also. And also this graph is undirected graph. So let us try to write the declaration part, that is graph edges I0. I0 means the starting node, means suppose there is a connection between 1 and 3, so we are considering 1 now, and post into the edges, that is I1, and we have to do the same thing in the reverse order because this is an undirected graph. Edges I1 and push back edges I0. So now we have the graph, and we have to make the answer variable, that is 0 initially, and solve function, or you can say DFS function. It will take the graph, the answer, and the previous node that will be initialized by -1. You can use 0 because we are not using 0 here. So it will start from 1 and then return answer. So let us try to write the function, DFS function basically. It will be int DFS, because in this DFS we have to return the number of nodes, and also vector ampersand graph, and then the answer, the previous node and current node. Okay, so we have to initialize another vector that will, sorry, another variable that will hold the sum of the nodes that we are already visited. Let us name it count, initially 0, and move to the for loop. I is equal to 0, I less than graph, that is, sorry, what is our current node, that is start dot site and I plus plus, and we have to check for the all adjacent nodes, and we cannot visit the previous adjacent node also. So we have to write like this, that previous should not be equal to graph of car and I. What is graph of car and I? Basically, that denotes the all the adjacent nodes, and if this adjacent node is not equal to the previous node, then we can move forward. Otherwise, we cannot. So let us make the DFS call. That will be graph answer. So now in the previous, it will be current node, and for the current, it will be the adjacent node, car and I, right? And it will return the sum of the nodes. So we store all the sum into the count, and also we have to check for the current position sum. What I am trying to say, basically in this part, we return only 2. In this part, it is 4, and this part, it is 3. So before summing up all these values, we have to check individually if the condition satisfies or not. So we cannot store directly in count. We have to make another variable, that is, let us say x, and if this x mod 2 is equal to 0, then it is even, and then only we can add +1 into our answer, and then we can add into the count variable. So we need to return count +1. Why count +1? Because when we are returning, because uh, here we have 2, 4, and 3, and we have to return all the sum values of the current position 3. So we have to consider this element also. So 2 into 4 into 3 +1. So that's why we are using count +1 here. So hopefully everything is right. Let us try to submit our code. Okay, so we have some error. That is, okay, sorry, I have put semicolon here. Okay, so the answer that is matching here, and let us use the example test case also. So it is correct. Let's try to submit. Okay, so it is working fine. So moving to the time and space complexity. Obviously, we know the time complexity of DFS, that is V plus E, and for space complexity, it will be the maximum height of the tree. And yeah, we are not using any visited array, so we do not mention the visited array here. And so this is the approach to solve this question, a slightly modification version of DFS. So hopefully the concept is clear to you, and see you in the next video. Bye.